Welcome back. In our last video, we discussed what a square root was and how to find the square root of a number. So we were looking at all of these perfect squares, and they're called perfect squares because any of these can make a square like these. You can make a perfect square out of all of these numbers because there's a nice, beautiful whole number when multiplied by itself will give you that number. So we discussed that since 4 times itself gives us 16, it can make a perfect square. Since 6 times itself gives us 36, it can make a perfect square. And for all of our whole numbers, we can make what's called a perfect square. So for this one, it would just be a square that has 1 on each side. And 1 times 1 means the area will be 1. But for this one, we would make a square that has 2 on each side. So it has 2 and 2. And so that makes a square with an area of 4. So we discussed how in the last video, and if you're a little bit confused, I recommend you go back and watch that video, about how we have all of these perfect squares. We should memorize 1 is the square root of 1. 2 is the square root of 4. 3 is the square root of 9. And I would recommend just practicing it like this. Go down your paper, write all of your whole numbers for the numbers we had to memorize when we learned our multiplication tables, and it was through 12 for most of us. I recommend going ahead and doing 13 and 14 as well, because sometimes you'll see problems with numbers that go up that high. So, and you're not allowed to use a calculator in most cases, so it's handy to have those memorized as well. So if I did the reverse of what I did over here, I would say 1 times 1, well, that's going to be the square root of 1. 2 times 2, that's going to be the square root of 4. 3 times 3, that's the square root of 9. 4 times 4, that's the square root of 16. 5 times 5, square root of 25. 6 times 6, square root of 36. 7 times 7, square root of 49. 8 times 8, square root of 81. 9 times 9, square root of, 8 times 8 was not square root of 81. 8 times 8 is square root of 64. 9 times 9 is the square root of 81. 10 times 10, square root of 100. 11 times 11, square root of 121. 12 times 12, square root of 144. 13 times 13, square root of 169, and I flipped those two numbers for 14, square root of 196. Some like to throw in 15, square root of 225. It kind of is an easy one for them to remember because it ends in the 5. But certainly you should know these by heart. That is going to help us when we have to find square roots that are not perfect squares, and that's what this video is about. This video is about when you have a number that you have to find the square root of. So for example, we have to find the square root of 18. We have to find the square root of 18. Well, it is not going to make a perfect square. Let's see why it's not going to make a perfect square. Let me scoot this down. We can try all of our whole numbers. Let's see. On a square, both sides have to be the same. So what number times itself could I use to get 18 for this square? Because that's the root of this square. What number times itself? Well, 3 times 3 is 9. Nope, not going to be big enough. 4 times 4 is 16. I'm getting close. 5 times 5 is 25, and I just went too far. So I really can't make a square out of 18. I could make something that has an area of 18, but it would be more of a rectangle. I could do a 3 by 6. Well, 3 times 6 gives me 18. That works for finding the area of 18, but it's not a square. So square root of 18 is not considered a perfect square. Some teachers will call it an imperfect square. Other teachers will call it an irrational number. But most teachers will call it a non-perfect square. So we have been challenged to have to find the square root of 18. The reason this usually comes up is because when you get to solving a Pythagorean theorem problem, the final step will be to find the square root of a number, and if that number is not pretty like this one, if it's not one of these that we just practiced, if it's not one of these nice, pretty, easy ones to find the square root of, you sometimes get stuck. You know how to do all of the steps in Pythagorean theorem, and yet you can't get to the right answer because the final step trips you up because you don't know how to find the square root of that number. So I have two ways to estimate this square root because that's all we're going to be doing is estimating it because it's not going to make a perfect square like this. It's not going to make a perfect square, but we're going to try to come up with a fraction or decimal that will be close to what it would take to make a perfect square. Because as we said, 4 times 4 was only 16. That didn't work. But we could try 5 times 5. That was too big. That didn't work. So if 4 is too small and 5 is too big, then we know it's going to be 4 and some fraction of a number, some part or decimal that's going to be required to come up with something where we can multiply it times itself and get 18. So let's look at two options. Option number one is if you just have to figure out the closest whole number that it would be. So when we looked at our square and we said, okay, well, it needs to be 18, and I know that 4 times 4 is only 16, and yet 5 times 5 is too much. It's 25, and we need it to be 16. Well, then I know it's going to be bigger than 4, but less than 5. So it's going to be 4 and some fraction of a number. It's going to be more than 4, but less than 5. Now, we're going to learn in just a minute how to use a number line to get pretty darn close to the approximate answer, to the estimated answer. But before you do that, sometimes if it's a multiple choice test or question, you can figure out the answer just by figuring out, well, should it be closer to 4 or should it be closer to 5? And let's see. I have the square root of 16 that I know is too small. That's 4. And I know on the other end I have the square root of 25. That's too big. That's 5. In between is the square root of 18. And we've already discussed in the last video about square roots how terrible I draw these. So the square root of 18 is going to be bigger than square root of 16, but less than square root of 25. So it's bigger than the whole number 4, but less than the whole number 5. Now, is it going to be closer to 4 or closer to 5? We're looking to see, is its answer, the square root of 18, closer to 4 or closer to 5? Well, square root of 18, is it closer to square root of 16? Let's see, that's 2 away. Or is it closer to square root of 25? That's 7 away. Well, I'd say it's much closer to square root of 16. So it's going to be much closer to 4. So we could say that if we had to estimate, it's pretty close to 4. That's a pretty big estimation, though, because we want to be a little more specific about how close to 4 it is. So we're going to look at a number line approach. Let me zoom back out. Pardon the bell. Excuse the bell. We're going to zoom back out, and we're going to use this number line. On a number line, you've got typically 0 in the middle and all of your positive numbers over here and negative numbers over there. We're not going to use the entire number line for this purpose. We are only using the portion of the number line that helps us solve this problem. And the portion of the number line that's going to help us solve this problem is going to be the portion that is between 4 and 5. How did I get that? Well, we're trying to find the square root of 18. The square root of 18. And we already established that the two perfect squares we know, because we can go right down our little memorization table here, We know the square root of 18 is not going to be 4 because it's bigger than that. So the square root, the perfect square before it is square root of 16, which is 4. The perfect square after it is going to be 5 because that's the square root of 25. And we know square root of 16 is going to be in between these two square roots. So because I know the square root before it is going to be the square root of 16, because I know that that is going to equal 4, the square root after it is going to be square root of 25. That's going to equal 5. We've already established that we know it's going to be closer to 4. The question now, we know this is going to be 4 and something. How close to 4 is that something going to be? What is that fraction going to be that helps us estimate the square root of 18? So on our number line, we only care about everything between 4 and 5 because that's where our answer will be located. So I'm going to put 4 up here, and I'm going to put square root of 16 because I know that that's the same place on the number line because it has the same value. 4 is the same thing as square root of 16. After that, I'm going to spread these out a little bit so I'm not following these lines because I just want to make it fit neatly. I have the square root of 17, then I have square root of 18, square root of 19, square root of 20. All of these square roots exist. They're just not perfect squares. So I'm filling in all of these non-perfect squares up to my perfect square of 25, which I know is the same as the whole number 5. So this and this are my perfect squares that I know the answers for. And I know that this one right here is what I'm trying to find. So I want to know, what is this worth? What is that? It's going to be bigger than 4. One more bell. Hang on there. It's going to be bigger than 4, but it's going to be less than 5. So it's going to be 4 and some fraction. So what's that fraction going to be? Well, I just took one whole and I just split it into how many pieces? Well, let me get a different color so this shows up better. I just split it into one piece here, another piece, another piece, another piece. All of these divided my whole into pieces. So how many pieces did I just split it into? Because remember, these were all how I found every square root between 4 and 5. So how many pieces was this split into? It was split into 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces. I apologize for the interruptions, but we do have school. 9 pieces. 9 pieces. If I took a pizza and I divided it into 9 pieces, one for you, one for me, one for the other person, 1, 2, 3, 4, 5, 6, 7, 8, 9. If I divided a pizza into 9 pieces, then each one of these pieces is a ninth, 1/9. We each get one of the 9 pieces. So we get 1 of 9, or 1/9. So I've just taken this one whole, because this was just one whole. Between 4 and 5, it's only one place on a number line if you're talking about the whole numbers. So I took the one whole and divided it into ninths. How many of those ninths does it take to get to square root of 18? Well, it takes 1/9 to get from square root of 16 to square root of 17, and another ninth to get from square root of 17 to square root of 18. So it takes 2/9 to get to square root of 18. So I'm going down my number line. Here's 0 way down here. I'm walking down this number line. I get all the way to 4, and I say, oh, that's not far enough. I've got to go 4 and 2/9 further to get to square root of 18. So the approximate answer for square root of 18 is 4 and 2/9. That is my estimation for what the square root of 18 is. Now I'm going to try one on a clean line real quick, and hopefully without all the chicken scratch it'll be a little bit easier to follow. Let me draw in a good line. to start with so that we have a nice straight line, because I can't draw a straight line without a ruler. And I'll do this one for square root of 28. Let's do square root of 28 is what I'm trying to find. I want to know what that is. Well, if I look back to my memorized perfect squares, I know that square root of 25 is going to be not quite big enough, and that's 5. Square root of 36 is going to be a little bit too big, quite a bit too big, and that's 6. But I know that square root of 28 will be somewhere between square root of 25 and square root of 36. So let's see where it will be. Square root of 25 is too small, and that's 5. The next number up would be 6, and that's square root of 36. That's too big. We want to stop and think, which one is it going to be closer to? Is it going to be closer to 5 or closer to 6? Well, between 25 and 28 is 3 jumps, and between square root of 28 and square root of 36 is 8 jumps. So it's definitely going to be closer to 5. So we know the answer is going to be bigger than 5, but less than 6. So it's going to be a fraction, 5 and a fraction, or decimal. So let's see what it is. We know that it's close to 5. How close to 5? So I'm going to start on my number line, and I'm going to say, okay, the only part that I really need to start with is 5, because that's square root of 25, and that's not big enough. I'll try to zoom in a little, see if it all fits. The next step would be square root of 26. Then next would be square root of 27, square root of 28, square root of 29, square root of 30, square root of 31, square root of 32, square root of 33, square root of 34, square root of 35, and up to the square root of 36. Because we know that one, we can stop. We know that's too big. That's 6. And we know square root of 36 is the next perfect square. 5 was the perfect square before it. It's right here. That's what we're trying to find the estimation for. So we know it's bigger than, we got all the way up on our number line to 5, and we said, oh, we got to go a little ways further, but we're not going to go another whole to 6. But this whole to 6 has been split into pieces when we tried to fit in all the other square roots. How many pieces? Let me use a highlighter instead. Maybe it won't look so messy. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces. So this whole has been split into 11ths. So I know my answer is going to be 5 and then some 11ths. How many 11ths is it going to take? Well, I want to get to square root of 28. So it's going to take 1, 2, 3 of those 11ths to get to square root of 28. So the solution or estimation for the square root of 28 is 5 wholes and 3 11ths further. So 5 and 3 11ths. Let's try one more. And then hopefully you'll get the idea. This is a really, really nice, handy trick to have, because most of the time you'll be okay just figuring out the closest whole number. But sometimes you have to be more specific, and so in those cases, that's what this is for. Let's see. I'm going to keep the number a little smaller just because it's easier to see. When you start to have big numbers, you have a lot of square roots in between them. And it can be done. You just take your time and mark them all out neatly. But for the purposes of showing you this demonstration, I want to make sure to keep the number kind of simpler. So let's see, we've done square root of 28, and we've done square root of 18. Let's do square root of 15. We're looking for the square root of 15. So the perfect square, we know it's not a perfect square because no number times itself that's a whole number will give us 15. because we know 4 times 4 is 16, and that's too big. And if we jump down to the next whole number, 3 times 3 is 9, and the square root of 9 is too small. So we're trying to see what number times itself will give us 15. And we know that square root of 9 was too small, and that's 3. Square root of 16 was too big, and that was 4. So I'm going to go to my number line. Well, first I'm going to say which one should it be closer to, because I can estimate the answer right now, and if it's multiple choice, I could probably figure out the one that's closest. So I know that square root of 15 is 6 away from square root of 9, and it's only 1 away from square root of 16. So it's going to be almost 4. So if one of my answer choices is almost 4 but not bigger, that's probably it. So maybe 3.9, 3.8, 3 3/3, something like that, 3 3/4, something like that might be an answer choice. Something really close to 4 but bigger than 3. Because that would be the answer, because square root of 15 is really close to 4 and it's bigger than 3. So anything bigger than 4 would not be the answer choice. You would not want to pick 4.5 or 4.2, because we know it's not bigger than 4 because it's not bigger than square root of 16. So I'm going to start on my number line, making my way down my number line. Okay, I get to 3, which is the square root of, let me keep this consistent. It doesn't matter which number goes on top and bottom, but I want to keep it consistent for you. 3 is the square root of 9. So I know that this is going to be where I'm going to start, because I'm getting really close based on this pre-work that I did. So after the square root of 9 is square root of 10, then square root of 11. These square roots really exist. They're just not perfect squares. They're irrational numbers that would go on and on forever and never repeat. So we have to estimate them. And that's what we're doing. We're estimating them because they're not perfect squares. Square root of 16, I know the answer to that. It's 4. It's a perfect square. So these are my two perfect squares. And so I know the whole number answers for them. Those are exact numbers. But I have to estimate any of these that are in between, that are not perfect squares. And I'm trying to estimate square root of 15. So this is what I want to find. Well, I know it's going to be 3 and some fraction or decimal of a number, and I'll show you how to get a decimal solution when we're finished. 3, and then when I look at this, I'll do it without a highlighter, just in case you don't have one handy. From 3 to 4 is one whole, and I'm not going to jump another whole. I'm only going to jump part of that whole. So I want to know how many pieces these have been broken into. 1, 2, 3, 4, 5, 6, 7 pieces. So all of these little pieces are sevenths. So how many of those sevenths do I need to get to square root of 15? Well, I need 1, 2, 3, 4, 5, 6 of those sevenths to get to square root of 16. So my estimation for square root of 15 is 3 6/7. Now, my answer is in a fraction, and maybe all the answer choices are in a decimal. We should know how to make a fraction into a decimal. So I'm going to do another video that shows you how to do a fraction, turn a fraction into a decimal, with a little horse and cowboy trick that keep you from messing up and forgetting which number to divide by what. But just assuming that you know how to do that, we want to take our answer 3 6/7 and make it a decimal. So 3, instead of saying 6/7, we want to make it point whatever it is. So we would take 6 and divide it by 7 to see what 6/7 is as a decimal. And 7 will not go in. I can't get 7 out of 6. So I'm going to have to put 0.0 because I can get it out of 60. But we don't want to change the value in here. So we have to make sure to put the decimal before we add the 0. So it still really is 6. Move that decimal straight on up before I forget. 7 will go into 60 how many times? Let's see. 7 times 7 is 49. We know that from practicing our perfect squares. So we know it's bigger than 7. 7 times 8 is 56. Not quite big enough. 7 times 9 is 63. Oh, we can't get that out. So we can only get 8 times. And that's 8 times 7. 8 times 7 is 56. So we're going to have, if we do our subtraction, 4 left over. So we'll add another 0 and bring it down. I would always recommend going out at least 2 decimal places. 3 is my recommendation because when you're dealing in percents, that's best. But 40. 7 will go into 40. We know it won't go 7 times because we practiced our perfect squares, and we know that 7 times 7 is 49, which is too big. So we'll do 6 times. 7 times 6 is, I'm sorry for that bell. I hate that it keeps ringing on. It's 42. Still too big. Oh no, that's why we work in pencil. 7 times 5 is 35. If we subtract that, we have 5 left over. And I'm going to stop there because I know enough to say that 6/7 is approximately 0.85 or 85 hundredths. So this could also be my solution, 3 and 85 hundredths. So here are my two estimations for the square root of 15. I hope that helps clear it up. Post if you have any questions, and I will try to get back to you.